Hi, my name is Zachary Onuh, and this is my presentation for Lab N5, Challenge Your Hacking Skills. So in this video, I will walk you through how I planned, organized, and performed a penetration test against my matter plottable to virtual machine using my Kali Linux VM. I will show you my scan results, explain how I assess risk based on those findings, and then demonstrate the handling changes I actually implemented on the target system. Here's a quick roadmap of what I will cover today. It's split into part A, where I explained how I planned, organized this penetration test. Why testing like this matters to an organization, and how I handled it if something went wrong along the way. Then in part B, walks you through my actual scans using Nmap, NITCO, and LSAP or ZAP and NUSOS. While in part C, I covers my risk assessment and the countermeasures I proposed based on those results. Then finally, in part D and E, I showed the real changes I made to metaplotables and what I learned from doing it. Before touching my tools, I started by defining the scope of this test, which was my metaplotable 2 VM, and I set clear boundaries so I wouldn't accidentally test anything outside that target. I established rules of engagement to keep the test safe and control the entire time. My overall approach followed the structured methodology described by Scanford et al. 2008, which emphasizes planning before any active scanning begins. I also mapped out the network first, so I understood what was working with, what I was working with, and I documented every step as I went. So I had have a clear record to reference later. Once the plan was in place, I organized the work into clear phases with a rough timeline covering reconnaissance, scanning, and reporting. I use my Kali Linux VM to run each of the tools against the metaplanable target in a logical sequence. So each step built on what I learned from the one before it. This kind of phase approach helped me stay organized, make sure I wasn't skipping steps. I also tried to keep my process aligned with the control guidelines from Fox 2020, particularly around documenting and managing changes as I tested. So why does this matter to an organization? Penetration testing exposes real, exploitable weaknesses before an actual attacker finds them, which gives security teams concrete evidence instead of guesswork. That evidence helps leadership prioritize where to spend limited security budget and justify investment in new controls. This kind of testing also supports the broader risk management functions described in IST's cybersecurity framework 2.0 next 2024, and doing it regularly strengthens an organization's security posture over time, while also helping meet compliance requirements across different industries frameworks. Things don't always go according to plan. So it's what talking about. What happens when a procedure fails or a step gets skipped? My approach is to stop testing immediately the moment something goes outside scope or a failure occurs. Rather than pushing forward from there, I document exactly what happened and why, I make sure to notify stakeholders before resuming anything. Any lessons from that failure get folded back into my procedure for next time, which lines up with the disciplined interactive approach Scanford 2008 recommended for security testing. Here's where I get into the actual scanning, starting with Emma. This scan discovered the live host and open ports on my metaplotable machine, and honestly it's revealed quite a few risky services running right out of the box. You can see in this screenshot the detailed output from my command line sessions, notably ports for Telnet and FTP were both open, which are legacy services known for weak or any encryptions. These early findings were really important because they directly shaped the deeper vulnerability work I did later. And this kind of discovery scanning is exactly the first step Scope 2008 describes in testing methodology. Next, I ran the lecture against the web server to check for common well-known issues. These two flagged outdated software versions and some risky server configuration settings. In this screenshot, here you can see the warnings it generated during the scan, including missing security data headers and a couple of exposed directory paths that shouldn't have been publicly accessible. These findings push me to go back and manually review the website more closely. Web-focused scanning like this ties directly into the risk goals outlined in the NIST Cybersecurity Framework 2024. For this scan, I used OWASP Zap to test the web application itself rather than just the server. It found injection risk along some weak sessions handling, both of which are serious concerns for a web app. You can see the alert list it generated in this screenshot. Zap also automatically mapped out the structure of the application through its spandling feature, which helped me understand what I was actually dealing with. These findings connect directly to the access control weaknesses I will talk about in part C, and they reinforce several of the control needs described in Force 2020. Finally, I ran a nuisance scan to get a deeper, more comprehensive view of the system's vulnerabilities. Nuisance produced a ranked list of weaknesses along with severity ratings, which you can see re-inflated in this screenshot. The most critical findings were outdated services and honestly some weak default credentials that really should have been changed. This can become the anchor point for my formal risk assessment, since its findings map clearly onto several of the controls in our control families described in Force 2020. Now that I had results from all four scans, I compared those findings against correct cybersecurity threats to figure out where the real gaps were. The biggest gap showed up in patch management, authentication practices, and access control overall. I ranked each risk based on how likely it was to be exploited and how much impact it would have if it were. If it were. My gap analysis leaned heavily on the control descriptions in Force 2020, while the broader risk categories were shaped by the framework in 2024. This process is really what set the priorities for everything I did next. Based on that gap analysis, I proposed a set of specific countermeasures. First, patching the outdated services that Scanner had flagged. Second, putting stronger password policies in place for every account on the system. I also recommended disabling services that weren't being used. Since that immediately shrink the attack service and enabling logging. So any future incident responsible response would response would actually have data to work with. Each of these countermeasures ties back to a specific finding and follows the control family described in Force 2020. Going into implementation, I expected fewer open ports once these changes were applied, and I expected stronger password to meaningfully cut down the risk of brute force attacks. My mitigation strategy was built around getting quick wins first. Changes that we are first to make but still had a real lasting impact. I learned on the list privilege principle from Force 2020 to guide quick access changes to prioritize. Overall, I expected reduced exposure across several of the most critical services identified during scanning. Handling a system really comes down to removing access and services that aren't necessary. Since that's what shrink the attack surface and lowers the odds of successful exploit. My overall strategy aligned with the core functions laid out in NIST Cybersecurity Framework 2024. Beyond just closing individual vulnerabilities, this kind of handling also improves an organization overall security maturity and builds resilience against stress down the road. Throughout this process, I kept coming back control catalog in Force 2020 to guide specific handling decisions. This is where on this part D is this is where I actually made changes to the system. I logged in locally to Metaplanable using the default MSFA main credentials. From there, I implemented three specific changes. First, I disabled one service that was clearly unnecessary and risky. Second, I changed a weak default password on one of the accounts. And third, I removed an outdated vulnerable application entirely from the system. You can see screen shots here documenting each of these changes as I made them. I picked these three changes specifically based on cost, how quickly I could implement them, and how critical the underlying vulnerability was. Disabling the unnecessary service costs also not almost noting and delivered results fast. Changing the weak password address a critical, easily exploited issue with very little effort and removed the outdated application, fixed something that was flagged as highly critical during scanning. This kind of prioritization followed a risk-based guidance for 2020, balancing effort against actual security benefit gain. Let's talk about what these changes actually face. Disabling that unnecessary service removed and unencrypted remote access part that could have been exploited easily. The password change directly reduced the risk tied to weak default credentials and removing the outdated application eliminated a known exploited piece of vulnerable code. All three of these features trace directly back to findings from my user scan area, and this map to several control family described in Force 2020. Altogether, my exposure dropped noticeably across these three specific areas. Comparing my expectations to what I actually observed, the results mostly lined up. Open pause decreased just about exactly as I had predicted going in. Password strength improved overall, though I would admit a couple of accounts didn't get updated in this round. These outcomes reflect the kind of measurable improvement described in NIST Framework 2024. The small gaps that did show up were mostly due to limited time for this assignment, but on the whole, my actual results closely match what I expected. Stepping back, the biggest lesson from this whole project is what having a system takes replanning and patience, and this is not something you can rush. Even a few small changes produce a noticeable reduction in overall risk, which was honestly a bit surprising. Keeping good documentation throughout turned out to be essential for tracking exactly what I changed and why. This whole approach reflects the continuous improvement mindset in 2024, and going forward, I had run future tests to cover more systems and go a bit broader in scope. So the last, is my the references I use. Thank you for listening.